Hey folks, so welcome back. We're still in NetBeans. What we want to do in this video is basically continue implementing our stack ADT in C. So as a first step there, what I want to basically implement is the construction and destruction steps, right? So stack create, stack destroy, as well as the actual struct for storing a stack as well, right? So these are the kind of three pieces I want to implement. So let's go ahead and go for it. First thing I need to do is create a new source file. So I'm going to create a new source file and call this, we'll just go stack.c. That seems like a pretty straightforward name. So I'll do that. Okay, again, I'll kind of delete these things over here. Just make some more space here. Let's see, and it already filled out some stuff here. I don't really need any of this, so I'll go ahead and delete that. So what do I want to do? I want to implement the stack. So my to-do list, right, basically is going to be to create the struct itself, then our create, and then our destroy. Destroy. There we go. Destroy. There you go. Those are my three things I want to create. Okay. So I have my specification over here. So what am I going to do? Well, I'm going to actually, let's see. Well, okay. First step. I want to implement this thing, so I should probably know what is exactly I want to implement. The way I'll do that is with an include statement. So I need to include my actual stack.h file. So this is my stack.c file. I'd include stack.h, not .c.h. All right, first step there. So now I kind of bring in all this stuff over here. And while I'm at it, maybe I'll copy paste this as well. It's nice just to have our file segmented a little bit so I can see what goes where. Okay, so now I have my C file now brings in that header file. Okay, so what should I do now? Well, I guess I'll copy some more stuff over. We should probably have our type definitions as well. Let me bring those over here. And eventually our struct's going to be under that. And then let's see, our function definitions as well. We'll go ahead and bring that over here. And then perhaps we'll go ahead and grab these two as well. And I can just create. I can go over those. Okay, so I'm just copy and pasting stuff from my header file. These are things basically that I need to actually deal with now. So then this will be this. Okay. So these are all kind of my different things I need to deal with, right? So I need to basically to complete this and then to complete these. Okay, let's save. Okay, so first thing I want to do is basically implement my actual stack struct or struct stack. So let's see. Let me comment that out. So what I want to do, right, is basically just define a struct. So I'm going to go and do struct stack, and then I'll have this in here. Earlier we talked about, right, what we should include. So we said we want to have a linked list head and then a size variable. Well, a size variable I can do easily, right? That's just an integer. Maybe though for the node I'll need to do a little bit more work first. I want to store all my data in a linked list, so that means I'm going to have to define a linked list node. So let's do that really quick. Struct node. This will be a struct basically for representing each node in our linked list. And we'll put in here, well, we need two things, right? We need basically a piece of data that's going to be in the node, and then we need a pointer to the next piece. So what is the type of the data we're storing in a stack? We used the term void star earlier, so we should probably use the same thing, right? We're going to store the same type throughout. So void star element is going to be the thing inside of it. And then I also want to have basically a pointer to the next node. So I'll do struct node star next. There we go. So that's our linked list node. Then going back over here. Okay, this is our struct. It's basically meant to store the contents of an object. We said, oh, hey, I need a head pointer as well. So let's go and add that. We'll go struct node star of, just call it head. All right, and I think that should be good. If you want to, you can actually go in here and basically change it up. So instead of writing struct node, you can just write node. We could actually have another type def for doing that. Now, go ahead and type it for you guys, just so you know what it looks like. I'll have to do a type def. This would basically just simplify my syntax. I would do something like this: type def of struct node, something like that. Right, and that'll basically create a new type called node, which really refers to struct node. Right, and then if I do that, right, then I can do things like if I put this in, right, I can refer to this just as a node star head, or over here a node star next. And actually that does look a little bit nice, so maybe I'll go ahead and leave that. All right, so those are our two new types we need, right? We defined a node, we defined a stack. That's all the data that I need to store. So let's see. Next step is going to be to create these different functions. So I need to create, and I need to create destroy. So this stuff here, right, I basically just copied it in from the previous header file that we had written. So what should I do here? Well, first thing, right, is let's go ahead and fill in create. So what am I going to do? I'm going to kind of change this, right? So now it's no longer going to be a forward declaration. Right now it's going to be an actual function. We'll call it, so stack underscore create. There we go. Well, actually, we can fill it in a little bit for this one as well. There we go. So this will be our two functions, okay? So actually, before we actually go and implement those, let's jump back over to our main really quick. So main is basically the huge application that we might want to use our stack in. How would this maybe start to look? Well, first thing is, right, if I maybe want to look at using the stack SER endpoint, I'm going to have to bring in the header file, right? So the header file is the way that I tell a program that, hey, you can use this code. So that'll be kind of the first thing I need to implement. So I'm going to type in here, right, and this is going to be the double brackets, or excuse me, double quotes, right, because it's like a local include file, right? So I'll use that. Now I can bring in basically my stack. Okay, so I'll have that as my first step. And let's see, just thinking off the top of my head, how would this maybe look? It would look something like this. I can glance over here, right? I can glance over here and say, okay, stack create returns a stack pointer. So maybe I have to basically create a new variable to store that stack. So I have something perhaps like this, stack star. We'll just call it stack ID or something like that. And then in here, right, we'd have something like stack SID equal stack create, right? And later on, maybe we have, let's see, we do something like stack destroy. I cannot spell destroy on SID, right? Something like that. Okay, so that's roughly how I'd start to use my stack, right? And then over here, right, I'd have all my stack operations. So stack ops, right? So push, pop, display, etc. would all happen here, right? So we basically would create this new stack variable, right? And then we assign it to a new stack. We'd say build me a stack, right? This is the equivalent of using the new keyword, right? Like using new in Java, right? And then we can do our stuff to it, right? And then we destroy it later on, right? So that's kind of what we're starting to do here, right? Starting to have this little setup here, right, where I can do my stack manipulation. So let's go ahead and save that. All right. Now, right now I can't really do anything though because I haven't implemented these. I don't think it'll build. Okay, it does build. Okay. It builds with one complaint. Let's see. Passing argument 1 is stack destroy from incompatible pointer type. Expected stack star star but got stack star. Okay, yeah. Real quick bug fix for you guys. I think over in the interface I had defined destroy as taking a double pointer. I kind of messed up here, right? And this is only this SID variable, right? Notice this is a stack star. There's only one star there. So I'm using a single pointer where I need a double pointer. Not too hard to correct though. I'll just add an ampersand in front of it, and now I'll have that kind of address of the address, right? So double pointer. And now it should build without warnings. There we go. Now it works. Okay, so this is how we start to use our stack. Let's go and implement our create and our destroy. So what do I need to do here? First thing I need to do is basically allocate memory for a new stack. So I'm going to write the following. Stack star new stack equal a stack star cast of malloc of size of stack. And there we go. All right, so what we're saying there is basically request some memory, right, for this new stack. Well, request some more memory for the struct, right, which is to store a stack, right, and then save the address to that in this new stack variable, right. So we're requesting memory to store a stack struct, right. Requesting memory to store that. Okay, so we have that. For the sake of making this stable, let's actually check to see whether it works or not. So I'm going to do the following: if new stack equal null, then there was a problem. Okay, else good to go. Okay, so this is maybe, we haven't really done this before, right? But there's kind of this chance that maybe I requested too much memory, and my operator couldn't find it, and I wasn't able to actually create that memory, right? And I don't actually have a stack to work with, right? So that's actually what we're going to check with right now. So what do I do here? I can basically do a printf statement, right, to say, hey, failed to create stack, something like that, right? Give a nice helpful error message, and then afterwards maybe do something like an exit. Exit of 0, right? Which I guess 0 technically means success. Let's change that to a 1 so it means fail. So yeah, if we are able to create the memory, then we'll go ahead and return an error message. Okay, so what if it did work? What do we need to do? We need to do a couple things. We need to basically, well, let me think for a second. We need to set up our two variables, right? Think of it like a constructor. So I need to set up head. So head should be, let's see, new stack. Head should be something like, it should be equal to null, right? Because initially I don't have anything there. And then size, right? Size should be something like just 0, right? Because it's like, oh, hey, I don't, you know, well, I don't have anything to start with, right? So set it equal to 0. All right, from there I can do return on new stack. All right, so it looks pretty good. I know people might get a little bit mad at the fact that I only have a return statement in one branch, but like this is going to exit the program, so I don't really need a return statement there, right? It's already going to end everything. So, all right, so that looks pretty good. I may run this. Maybe it'll work. I'm going to cross my fingers. Okay, it compiled and it didn't crash, so that's good. It did nothing, but it didn't crash, which is a good thing. All right, so what else do we want to do? We want to implement our stack destroy. So what does stack destroy need to do? Stack destroy needs to basically go through and free all the memory that was allocated. So that's going to be basically the memory for the list plus the memory for the struct itself, right? We need to clean up everything that happened, right? We need to clean up this thing over here, right? And eventually, right, you can imagine we're going to write code for manipulating this thing, and it's going to add nodes to it. We need to clean up that stuff as well. So in here, what should I do? Let me start by basically destroying that list inside of the actual the stack that we have here. So let's see, what do I go? Let's see, stat. Okay, node star equal. Let's see. So picture out you have the stack and you have a list inside of it. We want to go to each element of the list and destroy each of them. So node star iter. And we'll set that equal to basically star s. Let's see, star s. I need to dereference it kind of an extra time because notice I'm taking in the double star. So it's an address of the address of a stack. So one extra dereference there, put in an arrow, head. All right. So I have that there. Let's see. This is basically going to be a pointer, right, to the head of the list that the stack is using. And so now I want to kind of just loop over that and free everything that's inside of it. So let's see. Well, iter not equal null. Let's see. Well, I want a free iter, right? But I'll need to do some special work here. So I know I want a free iter. Well, I don't need to do a free. Let's see. The problem is always you want to move all lists, right? You want to free every element, but you also don't want to forget like where do you go next, right? You don't want to forget that. So let's save actually the next one. So we'll go iter n equal node. So node star n equal iter arrow next, right? So basically save a pointer to the next node in this n variable, and then we can basically free iter, right? Free the front of the list, right? And then update the front of the list to be like, okay, iter, you're now n, right? So basically, you imagine you're moving through the list, right? There's different pieces, if you would, right? One next to each other. And you have iter being the pointer to basically the first one. So you look at the first one, right? Save a reference to the thing that comes after it. Then free the first thing, and then update the reference to now be that second thing in the list, right? You do it over and over and over again until eventually there's nothing left. Okay, so we have that going on. Next, what we want to do is basically free the entire stack. So this is going to free the memory inside of the list, right? So this frees the internal list. Then we want to actually free the stack itself. Free stack. So we'll do a free on, this will be s star, right? We have a double pointer there, right? So one pointer basically gets me to the pointer that looks at the actual stack, right? So we'll step forward once, looking at that thing. Okay, and then as our kind of final step here, we'll do the following: star s equal null, right? So we'll actually set that set that variable that contains the stack in the outside scope to be null, right? So that nobody can ever use it again. Okay. So we have our s star, we have a free, so we should look pretty good. Clean up after ourselves outside. No dangling pointer. Dangling. Come on, I can do this. Dangling. No dangling pointer. All right. So looks pretty good. Maybe I'll add a couple more comments. So this is over here. Memory allocation failed. Memory allocation succeeded. Memory allocation. Okay, succeeded. There you go. All right. So this is our code here. Now we support basically creating and destroying this stack object. So let me go ahead and clean this, build this, run this, and see what we get. So it builds successfully. Will it run and not crash? Yes, it does. No crashing. All right. So yeah, now we have also this base code here, right? So we started going through this. Let me delete that there real quick. We now basically have our kind of our outline here, right? So we create it, we could do some stuff, and then we destroy it. All right. So this is kind of our progress towards our stack. We're obviously not done yet, right? We still need to basically implement all of these things here, but we've made some pretty good progress. Right now, we actually have a stack kind of object in memory. So that's all I got for this video. In the next video, we'll finish implementing all those different operations.